LambdaMart is not the only serious LTR path. YetiRank gives you another query-grouped ranker, and CatBoost makes the training loop practical in Python. You'll learn how the pieces fit into a workflow that trains a ranking model and checks relevance quality. I'm Professor Pi, teaching search and IR with simple Python. Ranking for search is simply about ordering results, so users see the best answers first. YetiRank is a ranking objective inside CatBoost that treats results as groups per query, not as isolated rows. That matters because relevance is relative. Users judge an item against the other items returned for the same query. If your model ignores query boundaries, offline metrics can lie and production behavior surprises you. People use CatBoost here because it bundles tree learners, GPU options, and a tidy Python API that keeps experiments short and repeatable. At a gut level, YetiRank is a listwise approach. It trains on the whole set of documents for a query, not one row at a time. Think of 3 results for a single query. You care most about which one is ranked first. YetiRank pushes trees toward ordering those items better, and CatBoost reports NDCG so you can actually see whether the top of the list improved. Its real strengths are query awareness and tight CatBoost integration. The trade-off is that you need decent query counts. Tiny query sets can lead to overfitting. We will build a tiny end-to-end demo. We create a toy query document table, convert it to CatBoost pools with group IDs, train a CatBoost ranker with YetiRank, compare it to a LambdaMart style baseline inside CatBoost, and then run a tiny re-rank step that shows how you would serve the model. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. First, we make a visible toy dataset that shows why query grouping matters. This snippet creates the smallest visible learning to rank table with query groups, documents, labels, and ranking features. Relevance failures in search are usually group relative, so the key ID column is the key idea. Documents compete only against other documents from the same query. The pandas PD data frame keeps the toy data readable, while still looking like retrieval features engineers already use, such as BM25, dense, and fresh. The rel column is graded relevance, not a binary click shortcut. The output confirms the dataset has multiple queries and enough documents per query to train a ranking baseline. Now that we have rows and QIDs, we need to give CatBoost the grouping information it expects. This example converts the table into CatBoost pool objects with group ID, which is the step that makes the task ranking aware. If query boundaries are missing or mixed up, a ranker can learn comparisons across unrelated searches, which is exactly the kind of offline mistake that becomes strange production relevance. Train holds 2 query groups, while test keeps one whole query aside, so evaluation stays group consistent. The features list is intentionally retrieval shaped: lexical score, dense score, and freshness. The printed result shows the split is by query group, not by individual document row. With pools ready, we can train a real CatBoost ranker using YetiRank and watch NDCG improve during training. This code trains the first real CatBoost ranking model with CatBoostRanker and loss function YetiRank. The point here is not to replace LambdaMart blindly, but to get a distinct model family into the same evaluation lane. Eval metric equals NDCG tells CatBoost to report a ranking metric that matches search result quality better than pointwise error. Iterations, learning rate, and depth keep the demo small and deterministic, with random seed equals 7. More iterations can give the model more chances to fit patterns, but it also raises training cost and can overfit small query sets. The output confirms the CatBoost model is fitted and has trained trees. Training one ranker is useful, but comparison is the real evidence. We add a LambdaMart-like baseline inside CatBoost to keep things fair. This snippet puts YetiRank next to a LambdaMart CatBoost baseline instead of treating the new model as automatically better. In retrieval systems, the useful question is whether a different ranker changes held-out query quality under the same features and split. Lambda model uses the same CatBoostRanker shape and hyperparameters, so the comparison focuses on loss function rather than accidental setup differences. The scored test pool top equals 3 call asks CatBoost for NDCG over the top 3 results, which matches the part of the SERP users are most likely to notice. The output gives both scores side by side for a clean baseline check. Once you pick the better model from the evaluation, you still need a serving step that sorts incoming candidates by score. This example turns the evaluated CatBoostRanker into a tiny serving-style re-rank step. Search teams need the last mile, not just a training metric. Candidates come in, Predict assigns ranking scores, and the system sorts documents by those scores. Josen keeps the better held-out model from the previous comparison. So the final list is tied to an evaluation decision rather than a favorite algorithm name. Ranked keeps the original document IDs and relevance labels beside the model score, which makes debugging relevance failures much easier. The output shows the top 2 served documents and their total visible relevance gain. In a production pipeline, this toy maps to a candidate generator, feeding top candidates into the re-ranker. You would replace the tiny data frame with real logging features, increase query counts, and persist the chosen model so the online scorer can load it and compute scores in a low-latency service. Quick summary in plain terms. YetiRank is a query-aware ranking objective inside CatBoost that optimizes list-wise quality. Use it when you have grouped queries and care about NDCG or the quality of top results. Watch out for small query sets and overfitting. Group diversity matters more than raw row count. If you want to extend this example, tune the number of iterations and the tree depth while evaluating NDCG at 3 on a larger held-out query set. And add 1 or 2 real retrieval features like log click rate or query document interaction to see how ranking lifts in practice. If short, practical IR helps, subscribe and watch the IR videos.